All right, welcome to the deep dive. Today we are diving straight into something that honestly most people probably have never even heard of.
Yeah.
But it's one of those things that makes your computer scream in a good way, even though you might never see it in action. TLP processing hints, or TPH, within the PCIe interface.
PCI Express, yeah.
Yeah, PCIe. Most of us think of PCIe as just that slot you jam your graphics card into, or maybe like a super fast SSD.
Right.
But it's really like the central nervous system for high-speed data inside, well, any modern computer. It's like,
Yeah.
the ultimate data expressway.
Exactly. And on this data expressway, information is zipping back and forth in these, well, they're like organized packets called, and I always get this wrong, transaction layer packets, or TLPs.
TLPs, yeah.
Now, these TLPs are just packed with essential details, but we're going to zoom in on this one. It's optional, but really clever feature, the TLP processing hint, or TPH. Okay, yeah, so imagine each of these data packets carrying like an extra little slip of paper, a heads-up note for the device that's receiving it. This note, this is the TPH, it's not strictly necessary for the data to, arrive safely, but it gives the receiver a little bit of advance intel on what's coming.
Just why? Why the need for this? What's the magic that this unlocks?
Well, I think the main goal of TPH is just to give performance a serious kick.
Yeah.
Really about allowing the receiving device to get a head start and prepare for the incoming data. And as you can guess, that preparation, it makes things much faster and more efficient, which I think is what we all really want at the end of the day.
Exactly.
We're going to dig into this, and kind of the research that we're going off of is called PCIe TPH Deep Research. Kind of a deep dive into the inner workings, and we're here to pull out the most interesting and impactful bits for you.
Okay, so let's unpack this. We're talking about better performance. But how does this translate to something that you would notice or care about?
So, yeah, I think the core benefit, like you said, is optimizing performance. When a receiving device gets advance notice about data, maybe it's a huge chunk, maybe it's a specific type of request, but it can, it can get ready. For example, if it knows a lot of data is coming, like when you're loading a complex web page with tons of images, it can pre-allocate space and its memory buffers to handle that flood of information smoothly.
So it's kind of like a restaurant knowing that a large party is about to arrive.
Yeah, that's a good way to put it.
They can get extra tables ready and the staff prepped so they're not caught off guard, and service is much faster.
Yeah.
For everyone, including the people just waiting for their food.
Right. And this proactive preparation, it leads to lower latency, which, less of that annoying waiting time when you click something and nothing seems to happen.
Right.
And then a higher throughput, meaning that more data can be processed and moved around quickly.
Right. So it's not just about the raw theoretical speed, but making the whole system feel responsive.
Exactly. And TPH also helps with, managing the system resources more intelligently. These hints can tell a device, what kind of data is coming. Is it a massive file being read or a series of smaller pieces of information being written?
Right.
And knowing this, allows the system to make smarter choices about where to allocate resources, like memory controllers, the pathways the data travels on, even the processing power needed.
So can you give an example of how this might play out, like something that we would recognize?
Sure. Imagine your computer is loading a game.
Okay.
A TPH might indicate that a large texture file for a character's skin
Okay, yeah.
is about to be read from your SSD. Knowing this, the graphics card could then, request a larger block of data transfer and prioritize its memory access so that texture loads quickly. And the character appears smoothly without any of that stuttering or weirdness.
Yeah.
Or if the system anticipates a burst of small writes, like when you're saving a document, it could optimize how those small pieces of data are grouped together and written to the storage, making the save process, faster and more efficient.
Right, so it's like having a really efficient loading dock that knows what trucks are coming and can direct them to the right bays and allocate the right workers.
Exactly. And the benefits, they ripple outwards. Better resource management can also lead to using less power, even making the whole system more stable, especially when you're, pushing it hard.
Right.
When resources are used strategically, there's less strain on everything.
Right. And, in the research it said there wasn't just one or two types of these hints. There's a whole variety.
That's a good point. It's not just a single on or off switch for hints. There are different, flavors of TPH designed to tackle specific bottlenecks or enable particular optimizations within the PCI architecture. Each type of hint carries unique information tailored to a specific aspect of how those data transactions are handled.
So how does this hinting system actually work? Where do these hints, where do they live?
So the TLP processing hint, is a specific field within the header of the transaction layer packet. Think of the TLP header as the address label and instructions on an envelope containing your data.
Yeah.
The TPH field is right there alongside all that critical routing information, providing its advanced notification.
So it's part of the data package itself,
Exactly.
not some separate channel.
Exactly.
Okay.
And the way that these, hints are encoded, the specific arrangement of, the ones and zeros within that TPH field, it's standardized within the PCI Express spec. This standard language ensures that any device that is designed to understand TPH knows exactly how to interpret the information being sent.
Right, so you need everyone speaking the same language for this to be useful.
Hmm.
You mentioned different types of TPH. Can we go through a few specific examples and see what kind of information they convey?
Absolutely. Let's start with the read completion boundary hint, or RCB. When a device sends a request to read data and includes an RCB hint, it's essentially telling the device that will provide the data, let's say your system memory, about how the data will be returned.
Oh.
It's setting expectations about the size and structure of the response. This allows the requesting device, like your CPU, to optimize how it sets up its internal buffers to receive that data.
Okay, so it's helping the device that asks for the information get ready for the answer it's going to get back.
Precisely.
Yeah.
Okay.
Another really interesting one is the relaxed ordering hint, RO.
Okay.
When a device includes an RO hint in a data transaction, it's signaling to the receiver that, it has some flexibility in the order in which it processes this particular transaction
Okay.
relative to others. Now, this doesn't mean the overall order of operations gets completely jumbled, but it gives the receiving device, like a memory controller, some leeway to reorder things internally.
Yeah.
In a way that makes its operation more efficient
Okay.
without impacting the final outcome.
So it's giving the receiver some breathing room. Yeah, think of it like a busy airport.
Right.
If one plane is slightly delayed, air traffic control might reorder the takeoff sequence to get other planes in the air more efficiently, reducing overall congestion and delays.
Right.
Similarly, with RO, a memory controller, might slightly reorder memory accesses to better utilize its internal scheduling and data pathways, ultimately, speeding up data delivery to your CPU.
Right, so it's like less internal congestion, faster overall flow.
Exactly. Then there's the no snoop hint, or NS.
Okay.
This is used in situations where the device sending a memory access request, it knows for sure that the data it's trying to reach isn't being stored in any of the CPU's caches or other caches in the system.
Mm-hmm.
So there's no need to go around and snoop those caches to check for a more up-to-date copy of the data. By setting the NS hint, the requester can tell the system to skip those unnecessary checks, reducing traffic and speeding up the access to the actual memory location.
Right. Less unnecessary back and forth, checking. That definitely sounds like it frees up resources.
Absolutely, yeah. The research also touches on some other interesting examples. There's the address translation hint, which provides the receiver with some clues related to how the virtual address being used in the transaction translates to a physical memory address.
Right.
Which can potentially speed up, the address lookup process, which is a critical step. And then there's the data tag hint, where the device sending the data can include a small tag associated with it.
Okay.
And the receiving device can use this tag for its own, internal bookkeeping, or to optimize how it processes that specific piece of data.
Okay. It's interesting how these seemingly small pieces of information can have such a big impact.
What's really interesting is that, even though these hints are optional, a device that's designed to take advantage of them can make much smarter decisions about how to handle incoming and outgoing data. This can lead to noticeable improvements in speed and responsiveness for the end user. And it's not happening in a vacuum. TPH can also work in conjunction with other PCIe features like quality of service settings to provide, even finer-grained control over how different types of data traffic are managed.
So where are we actually seeing TPH making a difference? What kinds of applications and hardware benefits from this the most?
I think TPH really shines in scenarios where you have a lot of high-speed data movement. Think high-performance computing, HPC. In these environments, you have massive amounts of data flying between processors, specialized accelerators, memory. TPH can be incredibly valuable for optimizing these transfers. By providing hints about where data is located, how it's likely to be used, devices can make better use of their internal caches and manage their memory resources more effectively. For example, a powerful processing unit might receive a hint that a specific set of data will be needed for a complex calculation,
Right.
allowing it to proactively bring that data closer.
So it's anticipating
Exactly.
in these intense computing tasks.
GPUs are another prime example. Rendering realistic graphics in games or professional applications requires fetching massive amounts of texture data, model information, and other assets. TPH allows the CPU or other initiating device to give the GPU a heads up about the data it will need. This lets the GPU start kind of prefetching that data into its own high-speed memory or caches, streamlining that graphics rendering pipeline, which leads to, smoother frame rates and a more immersive visual experience.
Yeah, so anyone who's been frustrated by choppy graphics in a demanding game can appreciate the behind-the-scenes work that TPH might be doing.
Absolutely. And then we have SSDs, solid-state drives, and other high-performance storage devices.
Right.
TPH can give the SSD controller valuable insights into upcoming read and write operations, as well as the patterns in which data is being accessed. This allows the controller to optimize its internal operations, such as, grouping multiple small writes into larger, more efficient ones,
Right.
a process called write coalescing, and also to preload data into its cache. In anticipation of future read requests, the result is faster boot times, quicker application loading, and overall more responsive feeling when you're using your computer.
Right, so those near instantaneous boot ups and application launches we've come to expect might have TPH playing a part.
Exactly. Even network interface cards, NICs,
Oh, wow.
can benefit from TPH. Hints about the type and priority of incoming network packets can help the NIC manage its internal buffers and processing strategies more effectively. For example, a hint indicating a high-priority packet, like one carrying voice data for a video call, can prompt the NIC to, prioritize processing to minimize any delay, which is critical for, a smooth and uninterrupted conversation.
Right, so you don't want your voice cutting out because your network card is busy dealing with some download in the background.
Right. And it's not just these high-profile examples. The research also suggests that TPH can be beneficial in embedded systems, industrial automation equipment, and other specialized hardware where efficient and timely data transfer is essential for a reliable operation.
It sounds like TPH, even though it's not a feature you see listed in the in the spec sheet, is doing some really important work. You mentioned that TPH is an optional part of the PCIe specification.
Yeah.
What are the implications of that?
Yeah, that's a key point to understand. Just because the PCIe standard defines TPH doesn't mean that every single device that uses PCIe has to implement it.
Yeah.
It's a design choice that manufacturers make based on the specific, performance requirements, cost considerations, and power budgets.
Right.
If a device isn't expected to see a significant performance gain from the added complexity of supporting TPH, or if keeping costs down is a major priority, the designers, that they might choose not to include it.
So it's a balance between the potential for increased performance and the added engineering effort and cost.
Precisely. And it's also interesting to note that the definition of TPH and the specific types of hints have actually evolved.
Oh, really?
As the PCI standard has kind of moved through its different generations.
Okay.
As technology has advanced and new performance bottlenecks have emerged, the spec has been updated to include new or refined hints designed to address these challenges and support the needs of different types of devices.
It's like they're constantly refining the language to keep up with the increasing demands.
Exactly. And because TPH is optional, there are important considerations around compatibility. Devices that do support TPH need to do so in a way that strictly adheres to the spec. This ensures that their hints are correctly formatted and can be understood by other devices. However, and this is crucial, devices that don't support TPH must still be able to communicate seamlessly with devices that do.
Right.
The PCIe standard mandates that if a device receives a TLP that contains a TPH field it doesn't understand, it just ignores it and processes the rest of the data packet as normal.
Okay.
This ensures that the optional nature of TPH doesn't create any compatibility issues across the vast ecosystem of, PCIe-enabled hardware.
That's vital. You wouldn't want to buy a cutting-edge graphics card and then it not work with your motherboard.
Exactly. The goal is to allow for performance enhancements where they make sense without causing any headaches in terms of interoperability.
Okay. So to bring it all together, what are the main things we should remember from our deep dive into TPH?
I think the takeaway is that TLP processing hints are an optional but incredibly valuable feature within PCI Express that can really improve the efficiency of data transfers by giving receiving devices advanced information about upcoming transactions. TPH allows them to prepare proactively, which translates into better overall performance in terms of speed and responsiveness, as well as a more efficient use of system resources across a wide variety of applications.
So having this peek behind the curtain at how data is being managed, it gives you a deeper appreciation for all the engineering that goes into making our computers work.
Absolutely. It's one of those foundational technologies that you might not see or directly interact with, but it plays a critical role in delivering the performance and responsiveness we've all come to expect.
Here's a thought for you. Given that TPH is currently an optional feature, what does the future hold for its adoption? As the amount of data we generate continues to explode, could we see TPH become a standard requirement? Or might we see even more sophisticated hints to further optimize the data flow?
That's a really interesting question about the evolution of interconnect technology. I think
Yeah.
it's certainly possible that, as workloads become even more demanding, the push for greater speed continues. The benefits of TPH, they might become so undeniable that its adoption becomes much more widespread.
Yeah.
Definitely something to watch as PCIe continues to evolve.
Yeah. And hopefully after this deep dive, you, the listener, will look at the specs of the devices you use every day with an understanding of the mechanisms,
Yeah.
like TPH, that are working to deliver that performance. Thanks for joining us on the deep dive.